So we're going to look at two trigonometric equations that we need to solve. And so just like when we solve a normal equation, when we solve a trigonometric equation, what we want to do is we want to isolate the variable. Now, before we isolate the variable, we want to isolate the trig function. So what I'm going to do, I'm going to put this trig function in the box. And so basically what I want to do is I want to isolate this box. I'm going to treat this as my variable. So I want to isolate this and get it by itself. So just as I would if this were 4 plus 4x equals 5, I would subtract both sides. I subtract 4 on both sides. So now I have 4 sine squared of x is equal to 1. I still have this coefficient of 4, so I divide both sides by 4. So now I have sine squared of x is equal to 1/4. We want to, first off, we want to stay with fractions, so don't use a calculator and change this as a decimal of 0.25. It's not really going to help you. But so now we have sine squared of x equals 1/4. But I want to know what sine of x is equal to. So what I have to do is take the square root. When you square root a fraction, it works that you take the square root of the numerator and denominator evenly and individually. So the square root of 1 is 1, and the square root of 4 is 2. But because we took a square root, it's going to be positive, negative. Now to isolate x, I have to do the inverse of sine. So if I take the sine of x, the inverse of that is going to be inverse sine. So now I have inverse sine. We'll write this out in 2 steps. I have the inverse sine of positive 1/2, and x is the inverse sine of negative 1/2. Remember, with inverse trigonometric functions, you're basically switching the output and the input variables. So you're asking, hey, which angle on the unit circle do I take the sine of and get 1/2? So where on the unit circle is the y value, the sine, 1/2? For this particular problem, we're looking for both positive 1/2 and negative 1/2. So if I look at that unit circle, where's the sine 1/2? At pi over 6 and 5 pi over 6. Where is it negative 1/2? 7 pi over 6 and 11 pi over 6. So that is going to give me all the answers. Again, inverse sine of 1/2, that's pi over 6, 5 pi over 6, and for negative 1/2, that's 7 pi over 6, and 11 pi over 6. And that is my answer for this problem. All right, so we're going to still look at our unit circle, and that's going to help us out in the future. But now we have this, and so this is a little bit different because now we're not taking the cosine of x, we're taking the cosine of 2x, and that is going to be a difference. That's going to make a difference. So we won't worry about that now, and we'll cross that bridge when we get there. So again, I have this cosine. I want to get that by itself. So I subtract 3 from both sides, so now I have cosine of 2 times cosine of 2x is equal to 2 minus 3, which is negative 1. Now I divide both sides by 2. So I get cosine of 2x is equal to negative 1/2. I have this cosine. I need to undo it. So I do 2x is equal to the inverse cosine of negative 1/2. So now we're looking for where the x value is negative 1/2. Where is the cosine negative 1/2? And that's here at 2 pi over 3, and that's here at 4 pi over 3. So if I look, I'm going to make 2 equations now. 2x is equal to 2 pi over 3, and 2x is equal to 4 pi over 3. Now, for the previous problem we did, these are all of the angles within one unit circle, so within 2 pi radians. So that's one revolution around the circle. But don't forget, we can go around an infinite amount of times, and we can look at coterminal angles. So for example, here, this is 180, but it's also the same measurement as 540. If we just add 360 to it, we go around one time. So with these, let's for a second assume we were looking at all angles, all coterminal angles. I would have to add one full circle, which would be 2 pi. What if I went around 2 laps? That would be 4 pi. 3 times would be 6 pi. So instead of adding just 2 pi, I add 2n pi. And this n stands for how many laps around, how many revolutions around the circle I am going. So if I'm looking at the coterminal angle after 8 revolutions, n would be 8, and I would add 16 pi. And so now I have this, but what I need to do is I need to get x by itself, so I need to divide both these sides by 2. So here when I divide 2 pi over 3 by 2, I just get 2 pi over 6, which is pi over 3, plus n pi. And then here I'm going to get x equals 4 pi over 6, which is 2 pi over 3, plus 2 pi over 2, which is n pi. Now, I am looking at adding with a fraction, so that means I need a common denominator, which in both cases is going to be 3. So if my denominator is 3, I multiply both numerator and denominator by 3. So now what I'm doing is I'm looking at the answers, and I'm going to stick for a domain so that x is between 0 and 2 pi. So I'm going to look at all the answers that happens for. So I have x equals pi over 3 and x equals 2 pi over 3, and that's fantastic. But what happens if I go around another lap around the circle? So n equals 1. Well, I have 1 pi over 3 plus 3 pi over 3 gives me 4 pi over 3. What happens if over here n is equal to 1? I get 2 pi over 3 plus 3 pi over 3. That's 5 pi over 3. Here, if n is equal to 2, I have 6 pi over 3 plus pi over 3, which is 7 pi over 3. But that's bigger than 2 pi. 2 pi is going to be 6 pi over 3. So there are no more angles. So these are my 4 answers. And this is important to realize that here these are the 4 solutions. And the general rule of thumb is this, adding the 2n pi. That's going to work for all these problems, but you really only have to worry about doing that and computing that when you have this, a coefficient in front of the variable. For this other problem we did, I didn't do that step because here, if I just add 2 pi, I'm not dividing by anything. So if I add 2 pi, I'm already outside of that domain 0 to 2 pi. But here, when I divide this 2 pi by, in this case, 2, I get n pi. So just adding 1 pi, well, that's still going to be inside my domain. So review this. There are plenty of practice problems you can check out. And best of luck as you prepare for the test.